We sometimes take for granted the complex engineering involved in the everyday components of an automobile. Ever wondered how a compact disc player works?
No.
Well, we're going to tell you anyway.
Sound waves can be represented as voltage signals. These signals can be stored as the magnetism of a tape or the digital points on a CD. Binary data is stored on the bottom of the CD, with zeros as pits on the surface that are smaller than a human hair. Here we represent the signal with 3 bits. However, it actually takes 16 of these bits to represent 1 voltage point. A laser reads hundreds or thousands of these points every second. Because the laser scans this data at a constant rate, the CD has to rotate at a varying speed, starting from 500 revolutions per minute on the inside of the CD and ending at 200 RPMs on the outside. The voltage signals are then fed into a coil which is inside of a circular magnet. The coil produces a second magnetic field. The forces between the 2 magnetic fields cause the cone to vibrate, moving air and producing sound. Of course, the sound needs to be amplified, and there could be interference from the bumps in the road or the steel in your car. Controls engineers, both electrical and mechanical, continue to address these problems.
The CD player, like every other car system, needs a source of power.
There have been a lot of changes in the automobile in the past 80 years. However, its main power source, the internal combustion engine, has essentially remained the same.
The engine is a giant chemical reaction requiring oxygen from air and gas. There is typically a surplus of air to ensure that all the gas gets burned in a combustion chamber.
It's all part of the motion of heat, thermodynamics.
What you see here is a single piston in a 4-stroke engine. A typical car will have 4 to 8 of these chambers. First, the piston moves down, drawing in a mixture of air and gas. Then, the mixture gets compressed as the piston moves up. In a gasoline engine, the spark ignites the gases, causing an explosion which pushes the piston down. This is called the power stroke. The exhaust gases are expelled when the piston moves back up again, and this 4-step cycle repeats itself, typically 50 times a second or more.
Chemical and mechanical engineers work on internal combustion engines with anywhere from 1 cylinder in a lawnmower to 4 or 8 in a car. There are also larger internal combustion engines found in ships and locomotives.
There is selection of materials for engine parts, thermodynamics of the power cycle, lubrication of moving parts, and of course the effect on and by the environment.